Okay, this question says, a ship is sailing north from the point A towards point D. Point C is 175 kilometers north of A. So here's C, 175 kilometers north. Point D is 60 kilometers north of C. So here's point D, here's C, and here is 60 kilometers. There's an island at E. The bearing of E from A is 55 degrees. So to get to E from A is 55 degrees marked here. And then the bearing of E from C, so to go from C to E, we have a bearing here of 134. This is shown in the diagram. Alright, so part A says, find the bearing of A from E. So what this means is we are at E and we need to find what direction we want to go to get to A. So I can just add to the diagram here. Bearings are always measured from north around clockwise. So if I draw a line here from north, this is north here, and we're looking for this angle here, this bearing around here clockwise from north. Now, since this line is north, this line is also north, these two lines will be parallel. If I was to continue this line down here, then here I've got parallel line, so this angle here would be 55. This side is a straight line, so this side is 180, so therefore the bearing of A from E is 180 plus 55, which is going to be 235 degrees. Alright, next part says find CE. So we need to find this length here. Now if we look at the diagram, we've got triangle, we've got an angle here, we've got a method we could find this angle here because we know this is 134. So let's just go ahead and put this one in. So this one's going to be 180 minus 134, which is going to be 46. And then since we've now got two angles, we would be able to find this angle here. So that's going to be 180 minus 55 and then minus 46, which is going to be 79. So this angle here is going to be 79. Now, we've got angle and a side here pair, and we're looking to find this side, and we've got this angle. So this would be a good candidate to use the sine rule. I'm just going to write the sine rule up here so we can remember what that says. So sine rule says that we're looking for a side, so A, which should be small a over sine A is equal to B over sine B is equal to C over sine C. So in order for us to use this, we would need to use here, we're looking for this side CE, so CE over sine 55 will equal 175 over sine 79. I'm just going to write that further down here. So part B, so it's going to be CE, which is what we're looking for, over sine 55 is going to equal 175 over sine 79. Alright, so I can rearrange that and say therefore that CE is going to equal 175 sine 55 divided by sine 79. Use my calculator. So if we do 55 sine times by 175 and then divided by 79 sine, that gives me 146. Okay, that's kilometers, I believe. Let's look at the scale up here. Yes, that's going to be kilometers. I've missed out part of the sign there. Alright, so that's in kilometers. Then, part C says find DE. So, DE is going to be this length, or this side along here. So we've got that one there. So in this case, we're now going to consider this triangle here, CDE. So I've just worked out how long this side is. I know how long this side is. I know this angle in between, so I should be able to use the cosine rule. So I'm going to redraw the triangle down the bottom here so we can see what's going on. So the triangle is like this. This is D, this is C, this is E. We know that this is 146. We know that that side there, CD, is 60. And we know that this is 134 degrees. Alright, so this is where we're going to need to use the cosine rule, because we've got two sides and the angle in between them. So the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos a. Alright, now b and c are the sides which we know here. A is going to be the side that we want. So as far as this is concerned, this is side A, this can be side B, this can be side B, and this is angle A here. So we would then work out a squared is going to equal 60 squared plus 146 squared minus 2 lots of 146 times by 60 and then times by the cos of 134. Alright, so we can then work out what that is. So a squared, let's use my calculator here. So I'm going to do this a little bit strangely. So we can do 134 and cosine first, multiply that by 60, multiply that by 146, and then by 2. So I've worked out this negative part here, and then that's going to be minus. Because this is minus, I'm going to negate that, and then I'm going to add 146 squared plus 60 squared. Alright, so that gives me 337,000, and then I need to square root that. So it's going to give me 193. So probably your calculator works slightly differently to the Windows one here. So I'd suggest you just work that out in a way that you're happy with. So A is going to equal 193. Alright. Now we look at the last part. It says when the ship reaches D, it changes direction and travels directly to an island at 50 kilometers per hour. At the same time as the ship changes direction, a boat starts travelling to the island from a point B. Point B lies on AC between A and C and is the closest point to the island. The ship and the boat arrive at the island at the same time. Find the speed of the boat. Alright, so if we come back to the diagram here, let me just rub out some of this other stuff, don't get confused. So, if we consider the point B, it says point B lies on AC between A and C and is the closest point to the island. So point B is going to have to be across here where this is a right angle. So point B is going to be just here. Alright, because it's got to be the closest point to the island, so that means this is going to be perpendicular, so that's 90 degrees there. Alright, so in order to work out the speed of the boat, we're going to need to do two things. So speed is equal to distance divided by time. So if we can work out how far the boat has to travel, and then we can work out the time it takes to get there, then we can work out its speed. So we come down here. So part D, our plan is that speed is equal to distance divided by time. So the distance is going to be BE. And then we divide that by the time. I'll come back to the time a bit later on. So in order to work out BE, we've got a right angle triangle here, and I've got a side here, and then what else have we got? Nothing else at all. Okay, if I work out the other side, if I work on this side, I've got this length here, I've got a right angle here, and I know that this angle was 46. So I'm going to redraw a triangle here. So I'm going to draw a triangle CBE. like so. This is a right angle. This is B, this is E, this is C. I know that this is 46 degrees. I know that that's CE we worked out earlier on was 146. Okay, so I can therefore use trigonometry and say that BE is going to be 146 sine 46. Okay, just because this is the opposite side, this is the hypotenuse. Sine of the angle is the opposite over the hypotenuse. So then to get the opposite, it's going to be the hypotenuse multiplied by the sine of the angle, which is what I've written here. Alright, so that's going to give us the distance, and then in order to work out the time, we know that the boat, it says when the ship reaches D, it changes direction and travels directly to the island at 50 kilometers per hour. So that's going to go along DE, which we worked out earlier. So we know that DE, the ship is going to travel directly down here. We know that that is 193 kilometers, and we know it travels at 50 kilometers per hour. So the time is going to be 193 divided by 50. So that's because it says the ship and the boat arrive at the same time. So time is going to be 193 kilometers divided by 50 kilometers per hour. So that's going to enable us to work out the time, and therefore we can work out the speed. So the speed is going to be 146 sine 46 degrees, and then divided by this 193 over 50, so I could try and multiply the 50 and write that up here. So it's going to equal that. So I can then use my calculator. So I do 46 sine multiplied by 146 multiplied by 50, and then divide by 193. So that means it should be 27 kilometers per hour, 27.2. Alright, that concludes the question.